In ion-dipole interactions, you're going to have an ion, which is going to be a full-size charge, and it's going to be interacting with a dipole, or a molecule with a dipole, which means that it's going to have a partial charge. So a full to partial. That's going to be the strongest out of all of our intermolecular forces. And this is going to allow us to explain how ions can be dissolved in water and other polar solvents. Picture NaCl. So when it's sitting together, it ends up being a neutral formula unit, and we have the Na plus and the Cl minus. Now they're going to be sticking together with ionic bonding forces, and so we're expecting that to probably be somewhere up around 1,000 or so for the kilojoules per mole, connecting these two together. What can help them separate to become Na plus and Cl minus? You can have some water molecules swarm in here and help pull them apart. And those intermolecular forces between the ion and the dipole of the water, like you see down in this table, are going to be big enough that when you have multiple water molecules around it, actually we'll do it like this. Remember, if we have an HOH, we have it like this. Oxygen will have the partial negative charge and will be pointing toward the sodium. So we're going to have more than one water molecule helping to pull this thing apart. And I'll just draw a few like boomerangs real quick. If I can have 4 or 5 of these water molecules, that's going to be enough to completely negate the amount of energy that was stabilizing the Na and the Cl. And don't forget, we're going to have the stability coming from the Cl minus being pulled away by these water molecules as well. And if this is looking too crowded to actually be something that would happen, remember, we can do this in 3 dimensions in reality. And so we're going to have water molecules swarming from the front side, from the back side of the screen, and the ones that are in the plane of the screen. So there's going to be lots of space to get these water molecules around them and help pop them apart. That's what we're talking about for ion-dipole interactions.